2 of the Marginal Zone Macrophage grant. And the basic question is, do other macrophages or dendritic cells affect the marginal zone macrophage? We're looking at mechanisms where the marginal zone macrophages can have all of its proper functions, which are, the number can vary, their location can vary. The number can vary, for example, claudin liposome get rid of them, but there's other ways to get rid of them too. If you get rid of some of the critical survival or maintenance factors. The location might be a key thing. We know that things such as CCL19 and 21 signaling through CCR7 is critical because in the PLT mice, this is knocked out and the marginal macrophage is flowed out. And it's marginal zone macrophage specific. So location. Phagocytosis is critical. We might mention this first because Marco and SRA1 is critical. In fact, it's so critical that in lupus patients, they have increased anti-Marco or anti-SRA1. That correlates with their anti-double-stranded DNA. In NZB mice, they get elevated levels of these two antibodies, and that correlates with anti-DNA and disease. They should show also that, of course, that they correlate with MDA, the increased phagocytosis clearance, but probably they'll do that. And then the signaling pathway, which we'll get into, so that's critical. So those are the types of things that we want to just discuss, and it'll reflect this over and over again, the number, function, phagocytosis, and then the mechanisms for regulating all that, as related to the milieu of cytokines that are outside. And I can tell you what those are real fast. Those are things like interferon alpha is one of the main ones that modulates all that. But then there's IL-23 that modulates that. We'll get into that. There's TNF that modulates that. And eventually, I'll just give you a hint over here. The final out thing, one of the molecular mechanisms, will be phosphoflow. And we're going to look at all these things. For example, one of the sort of practical aspects of all this is Enbrel, which blocks TNF, makes something worse. Anti-IL-23 might make it worse, but anti-interferon alpha makes it better. So we look at the various pathways. Enbrel might make it worse by blocking P65, NF-kappa B, and then that, which blocks interferon alpha. So if that's blocked, interferon alpha predominates. IL-23 might be worse because, IL-23 might activate phosphorylate AKT, and so if you block that, it could get worse. The cells might not survive, and PI3 kinase pathway is involved. But interferon alpha makes it worse because you get the JAK-STAT, and we know what that is. It's p-STAT1. So, interferon alpha makes it worse. A blockade of that will make it better. So Enbrel and IL-23 blockade makes it, TNF and IL-23 blockade makes autoimmune disease worse, whereas anti-interferon makes it better, and we can keep that in mind as the final molecular mechanism with phosphoflow. But over here, so that's kind of what I mean by signaling, but you can see that's complicated. So now you got to order this right. You can see I keep fussing with this, but maybe the main thing is the readout. For the whole thing, we want to lay the groundwork that we're going to, we know that we have a paper and all that other stuff. IL-23 in the germinal center is bad. It causes germinal center. It causes Th17 development, and that causes IL-17 germinal centers, pathogenic autoantibodies, the whole business. So IL-23 is a bad cytokine inside. But basically you want to say that but also we got other papers showing that the marginal zone, loss of the marginal zone is also deleterious because then the marginal zone B cells go inside under the influence of interferon alpha. So in every case, we'll give them apoptotic, we'll do some manipulations, give them mice apoptotic bodies and watch them go inside, watch them do, stimulate these germinal centers. Now, so that's kind of like the first thing. The second thing I thought is, what about the macrophage environment? Because we're going to talk about red pulp macrophages a lot. We might as well bring them up next. They're F480. They got a problem in NZB mice of some kind. The F480 macrophages, just to remind everyone, they maintain marginal zone macrophages. We know that. We get into the idea that marginal macrophages maintain marginal zone B cells by day. But what maintains marginal zone macrophages? Well, these F480 red pulp macrophages are there, and they produce maybe 2 or 3 factors. One is lymphotoxin beta. That's known to maintain marginal macrophage. But the other 2 is TNF and IL-23. IL-23 is our data, which we'll probably bring up right after this. TNF is data that kind of comes up indirectly from the GATA. When you get up here, you get to the MFGE8 plus TIM4 knockout together are not a problem, but if you give interferon alpha, it causes a problem in tolerance, and I believe they showed it's also tolerance in MZMs. But if you give TNF, it inhibits this. So this gets back to the idea that TNF production and other pro-inflammatory cytokines, so you might start like this, pro-inflammatory cytokine production by red pulp macrophage actually is a beneficial thing. They form a protective barrier. They're the first thing that cells and bacteria and viruses see. So you really need that protection and through the TNF and IL-23 production, those inflammatory cytokines. You might think it'd be counterintuitive that occurs, but it seems to be important. And furthermore, the same cytokines maintain, or maybe I should say, inhibit interferon alpha, signaling, as we mentioned over there. So there's B is red pulp macrophage. C is going to be getting into SLE, and I talked about this a little bit. But here, one thing that's really critical is, in addition to anti-Marco and NZB and SOA1, like I just talked about, think of this, SHIP1, this might be a time to introduce this, and that'll take care of C and E here. SHIP1 is defective in SLE. So you start out, well, what does SHIP1 do? SHIP1 knockout mice, interestingly, have been shown to lose marginal macrophage from around the follicle. And then, importantly, bring out MOMA1 macrophages are okay, they're not lost. So really, lupus and all this is a marginal macrophage problem, just in case anybody brings it up. And SHIP1 is a tolerogenic signaling pathway. It's like an I-10, as you said. Maybe it relates to interferon alpha. So we want to talk about SHIP1 as being one of the key regulatory pathways. Okay, so with this in mind, with the red pulp, with a number, location, this, did I mention PLT? Because PLT knockout don't have, I think I did mention, CXCL19 and 21, CXCL7. So that's an important regulator of the location, as well as possibly S1P, but we might get into that. Pegostosis is Marco, and then signaling is SHIP1. That's all this. It integrates the interferon alpha and TNF signaling, maybe IL-23, and we talked about it. Okay, so then you get over there, that's the introduction. Then we get to the cellular mechanism, and it's basically manipulation of marginal zone macrophages and red pulp macrophages. Since we talked about red pulp macrophages, one thing to do might be just what I think we already did, is take red pulp macrophages with without IL-23, 23 knockout versus 23. We know that 23 knockout loses the marginal zone. So we want to do it early before the marginal zone is lost and just transfer in red pulp macrophages that do or don't express IL-23 and prevent this loss of marginal zone macrophages. Caveat there is they might go inside. That's why you can't just collagenate liposome treatment and give them, because then all the 23 red pulp macrophages will go inside and cause the germinal center, Th17 germinal center, which is actually what happens. The disease gets worse if you deplete in the 23 knockout. So we want to kind of downplay that. But so we'll do it as a preventative measure, and we'll kind of make it sound like the marginal zone barrier will be intact and be maintained. The other thing is to manipulate, this is to manipulate the red pulp macrophage, manipulate the marginal zone macrophage. Here, as we said over here, that we think the marginal macrophage is deleteriously affected by interferon alpha. That's over there. It's back here. When you look here, you see interferon alpha does what? It does something over here. Interferon alpha signals through the NGF and TIM4. Interferon alpha is critical, and here too, in the SHIP1. So interferon alpha has lots of intercepts for this. And so if you could block interferon alpha signaling in a cell in the marginal macrophage, you kind of get the impression it would be in good shape. So you take the interferon alpha receptor knockout versus wild type BXD2 mice, get their marginal macrophage, and transfer those in. And the interferon alpha receptor knockout marginal macrophage repopulated mice will be pretty much non-autoimmune. And then you can stress neither by giving them CpG. Okay, and so those are manipulating of those two cell types. And then you manipulate the signaling pathway of the cell, and it's sort of the same thing in parallel. You take the PLT marginal zone macrophages. Here, the guy already did it. The PLT knockout has a defect in 19 and 21 production, CR7. So if you give the PLT marginal macrophages back, they're not going to localize well in the BXC2. But if you give the wild type, they will. But if you do it the other way around, they'll be okay because CXL 1921 is produced here. No, it must be produced out here. So, you know, it pools the marginal macrophages here. I'm not sure whether it's produced here or here, but you know, it's something to worry about. But those are manipulating themselves by the PLT, and I believe it's marginal macrophage PLT. I think the guy did the total cells. And then the other cell type to manipulate is marginal macrophage SHIP knockout mice. Here, it's similar to what we did up there, but you do it with the cell. You take the SHIP1 knockout marginal macrophage and see if that works. And see, you know, if they have SHIP1, everything's fine, or if they're missing it. If they have SHIP1, you maybe coordinate, deplete, put in the SHIP1 versus knockout versus wild type. The wild type will repopulate and give resistance to interferon alpha. But one other thing is to note, BXC2 have a defect in SHIP1. They're low. So you might think what you really need to do is figure out a way to enhance SHIP1. Here you're getting into things like transfecting cells with the vector or somehow enhancing SHIP1 expression. So, you know, you can see we're getting cells and then pathways. And then you get to the detailed molecular mechanism over here, wrapping that with AIM2B, molecular mechanisms. And as we came up with, what I was thinking of is start out with phosphoflow, you know, because phosphoflow, we all think this is the mechanism, this little thing here is actually the mechanism. Interferon alpha is working against the beneficial effects of IL-23 and TNF. So you might just, you know, you can treat the mice, you know, with, we'll have the mice already, and we'll show this works. We have the mice with interferon alpha receptor knockout. You know, some of the transfer experiments here, we just take those mice and carry them over and study this in vivo, in vivo, and then you sort the cells. You sort the MZMs, and with
you don't need to sort, just facts.
or the facts analyze with MZMs with you know, you stain it with the Sino1 and Marco, just like Howley does. And they should also be F480 positive. And then you do the staining for PAKT, PP65, and interferon, STAT1, I guess, PSTAT1. You know, Jonathan Irish knows about that. Did I say PAKT? Yeah, I did. Okay, so that'll do that. And then, in addition, that'll be like straight out of the mouse or with manipulated cells. The other thing that brings up is a little practical aim. You know, treat the mice with Enbrel or anti-IL-23. We think that'll make the mice worse. Enbrel causes antibodies in lupus, so we think we know how that works. Anti-IL-23 we also think will be bad. IL-23 blockade will be bad because it'll lose marginal macrophages. But really, what's the mechanism if that's the case? Whereas interferon alpha is bad through PSTAT1, but anti-interferon alpha might be good. And of course, that's a consideration for a therapy for lupus that's ongoing. So maybe this might be a biomarker thing. We could sort of see which patients might be manipulatable to which pathway. And, you know, ones that have, that interferon alpha, anti-interferon alpha works the best on, say, circulating macrophages, we could talk about that, then they might have implications for marginal macrophages. And also, it may be that for the trials, you not only look at anti-DNA, but you want to look at this other marker for circulating apoptotic cells, which is MDA something. You know, we keep forgetting to look at that. And that's phosphoflow. And then I would say wrap it up by looking at the new part, and more zoom, RLR versus TLR, because RLR might enhance TNF and IL-12 versus TLR signaling might enhance interferon alpha. So you give, for RLR, you might administer poly-IC or some of those other ones. For TLR, you give CPG. And we've got to figure out why SHRP1 is down in BXD2 mice. So I think that's it. We'll talk about the marginal macrophages, all the different aspects in the introduction, then the cellular aspects here, and the molecular aspects emphasizing phosphoflow at the end.